So hello and welcome to the next video, and this is an additional one because we already tested our hypothesis, but I wanted to show you two more things. The first one is how to make the same analysis using regression analysis, because we used ANOVA and multivariate test, but we also can run regression. In this event, we need the dummy variables because, look at this one, if we go to Analyze, Regression, Linear Regression, then we have, first of all, one dependent variable, so we need to run for different variables 4 regressions. We have 4 dependent variables. And for independent variables, we have only one option. We don't have categorical or nominal variables here, which are called factors. In this event, we have to include the dummy variables, because it will just show is the person in a manipulation group anger or is not in the anger group, is in fear group or not, and so on. We take the first one, this scale, as a dependent variable, and now we want to see whether manipulation worked. But if I add this variable, it is coded as 1, 2, and 3. SPSS will automatically understand that 3 is actually 3 times 1, and it is not the case. In our event, we need to add the anger dummy, the fear dummy, and we don't need to add control group dummy, because this variable will be redundant. It will be compared against the one that we didn't add. If we add it, SPSS will automatically throw one of them out. Let's check it. Let's go to statistics. We need estimates, model fit, R² changed. Yeah, I think we can add the R² more or less. And continue. In options, we don't need to do anything, and bootstrapping, we don't need bootstrapping for now. And let's click on OK and see what happens. We received the regression. This is the, we added 3 variables, and look at this table coefficients, and look at this one. One has been omitted. This is the fear, and control group is here, so anger was automatically omitted just because you are either in a group fear or group control group or anger. So you cannot have no group. You will be in one of 3 groups. It's like comparing the colors of the cars. You don't have a car without the color. You can have the car in black and red and green color or other colors. You can compare black against red and green. You can compare green against black and red and so on, but you cannot compare black against nothing, because there cannot be a car without the group, without the color. The same happens here. And to make our life easier, we make linear regression, and actually would like to compare against those people who were not in the emotion state, so who were in control group. That's why we just omit this one, and then in this table we will see the 2 variables, which is fear and anger. Let's click on it, and we do have here fear and anger, and what you see here is that now it is compared to control group. So as compared to control group, behavioral inhibition is statistically significant different, is lower in the anger group, and fear is not significant. Fear can be significant as compared to anger, but not against the control group. This is how you interpret the results. The second thing I want to show you is the R² value. We go for adjusted R² and adjusted R², and it explains, it shows how much variance we explain with these variables in our dependent variable. So in the dependent variable behavioral inhibition, we explain 11.9% of variance by the variables anger and fear. And finally, these 2 things I want to show you more. First one, what means this B? Actually, it means that anger, if it is anger, it will be a lower level of B, but in how much lower? And remember, it will be not a 1 unit, but it will be a part of standard deviation. It will be minus or 6.2 standard deviations lower if you're in the anger group as compared to the control group. And fear group will be 0.22.9 standard deviations higher as compared to the control group. So it means if people are in one of the states on the behavioral inhibition scale, standardized behavioral inhibition scale, they will have a lower or higher scores, and this is in standard deviations measured. That's why it's called here unstandardized B, but as we standardize the coefficients, this will be the standardized B. So if you report this value, if this is the standardized coefficient, instead of B, you write here beta. Beta stands for a standardized B. Finally, I want to show you how you test artifacts. As it is a regression, we test for the manipulation, but we can also test for gender. And we can add gender. It is already a dummy. It is 1 for male and 0 for female, so we don't need to recode it. And we can add age because it's scalable variable. So you can work only with scalable variables here. Or if it is a not scalable variable, you have to recode it as dummy, and it will become a scalable. It will be a kind of 0 or 1. And click on OK, and at the end we receive the results here. You can see significance. It works only for anger as compared to control group. And gender is not significant, age is not significant. Gender means if you are male, your standardized B, it will be standardized B, although here is written unstandardized, but as we standardized it before, it will be standardized B, will be 0.49 higher, but not statistically significant as compared to females, because male were coded as 1 and female as 0. And now you have to repeat the same test for all other factors and see whether we can support our hypothesis. Actually, we'll come to the same results, more or less, as we had before. No significance for the first BIS skull. Will be also no significance for the second BIS skull, BISD. Nothing significant. And for the third one, there should be something significant. And let's see, and we do have significant results. And namely here we see that fear is different from control group. Anger is not different from control group, but can happen that anger is different from fear. To test it, you just need to include control group and delete fear, and then anger and control group will be compared against fear. So more or less, this is how you make the same test using regression analysis, how you calculate your R-squared or adjusted R-squared, and actually how you test your hypothesis.